Start off with, I'm going to be a little bit of a Jeremiah. There's a disaster coming. The end of the world is near. How near, I don't know exactly, but I do believe that there are a number of trends that spell some fairly significant changes in the future in our profession and in the way that we do things. Some of these things come from forces within the industry. Right now we spend over $1 trillion a year on IT products, and at least 40% of that is absolute total waste. It does not result in any deliverable product. It delivers in products that are late, bloated, underutilized, and a huge cost. I have no problem overestimating the ability of corporate America, at least, to put up with these intolerable costs for some time in the future. But sooner or later, they're going to say this is economically untenable, particularly as the world's economy becomes more and more suspect. Related to that is that there is somewhere between 3 and 5 trillion lines of code out there in the world today. That's a lot of code. It is approaching the point where nobody has any clue what it is, where it is, what it's doing, why it's doing it, how to fix it. It's just getting immense. So the code base itself is becoming untenable. The pace of change that's faced by enterprises, by people that are in business, has been accelerating dramatically over the last 50 years. The pace of change in our ability to respond with IT services and products hasn't even come close to matching that same pace of change. When I started in this profession in 1968, the average time for a project, taking all the corporate projects put together, the average time of delivery of a project was just under 3 years. The shortest delivery time was measured in a year, longest in 5 or 6 years. One of the largest companies in the United States, in fact, the largest privately held company in the United States, a year ago initiated a 10-year, $1 billion project for their IT systems. The discrepancy in these kinds of things leads to a great deal of inertia. So if you are a young, agile, entrepreneurial kind of a business, or a big business and you want to be young and entrepreneurial and fast-paced and adaptive to the current circumstances, you don't have a prayer because your IT systems are going to slow you down and force you to do business the way that you were doing business at the time that those IT systems were first conceived and initiated. So the Cargill Corporation, shouldn't mention their name, the American corporation that started this 10-year project, they are basically freezing the way that they are doing business for the 10 years that they are in development of this product. You know that no one's going to be allowed to come in with change requirements. They get through. They're spending $1 billion on this software project. And how long is it going to be before a manager says, oh yeah, we have the budget for a change? You know, you just spent $1 billion. How are you going to get any change? So that company is basically locking itself into its current state of operations for 20 years. That is untenable. The other one is the treatment of human beings not as resources, as things that have value, the things that contribute value to the business, but treating them simply as commodities. The philosophy of computer science, the philosophy of software engineering, right from the beginning, said we have this huge crisis. We have a huge demand, and we do not have enough talented people to satisfy that demand. We don't know how to create talented people. So what we're going to do is we're going to commoditize people. We're going to reduce them to their lowest common denominator and then compensate for that inability with method, with process, with things of this sort. And the increasing effects of these kinds of things ultimately is supposed to lead to an automatic programming where all of you are replaced by the computer because you don't add anything. I don't like being treated as a commodity. At the same time, these forces are creating this huge precipice. The world around us, or our understanding of the world around us, is changing very dramatically. It's no longer the deterministic systems of 18th and early 19th century physics. It's no longer the world of Mach and Einstein, where they said, if you can tell me the position of every particle in the universe today, I can tell you exactly what the universe is going to look like 20 years from now, because it's all subject to rules, regulations. The problems are changing. We're dealing with complex problems. Complex problems have these kinds of characteristics to them. First of all, they're decentralized. If you look at the way that we have been treating problems and problem solving for the last 50 years, all we have been doing is reinventing the mainframe of 1950. If you look at the iPhone in your pocket, it's a mainframe. We have added one embellishment. We've done client-server, so that the iPhone in your pocket is connected to a server somewhere, but client-server is also 1950s architecture, and we haven't advanced beyond that. We can no longer afford to have these massive centralized server kinds of farms right now. They're a real ecological threat. Google should, if it was a really ethical company, situate every single one of its server farms exactly next door to some big hydroelectric dam or an atomic generating plant, because 90% of the electricity used to run that is lost in transmission, and they consume a lot of it. We need to think about these decentralized kinds of problems. It also has to do with the fact that there's no authority, there's no command and control kind of structure. You've got to figure out a way of distributing and understanding how this command and control is distributed. Continuous evolution and deployment is a big one. We are still locked into an episodic way of doing business. We talk about agility, but we talk about agile projects. So you are still trying to be agile within these big blocks of time, these 18 months to 3-year period of time, and you're trying to deal with a large project. You need to be in the position of being able to deliver something that alters the business or the way that the business does things on the exact same time scale that they encounter the need. And we can't do that yet. The erosion of the people-system boundary. This has some historical interest. Who were the first computers? What was the first computer? The first thing that carried that notation. If I said, you are a computer. Yes, I was talking about a bunch of women in England, in Benchley Park, that were doing calculations in ballistics. They were the first computers, were people. We're getting back into that we can no longer imagine that we're going to put all of your intelligence, all of your experience, all of your knowledge into a machine somewhere so that it can make decisions. We're going to have to figure out how to accommodate that interface, that part of the knowledge that's going on in this software is in your head. And then normal failures is a real big one. Right now, today, somewhere in the world, around 10% of the internet is dead, totally dysfunctional. But the internet runs just fine. I was on it just a minute ago. This situation of normal failures as opposed to the perfection that was the goal of software engineering and computer science is a big deal. So how do we address all of these kinds of threats? Computer science can't do it. Computer science is still stuck in physics envy. They're still trying to be a science in the classical physics sense of the term. We can't fix it. Computer science also has this kind of hubris that everything is a computer. I've seen people talk about, there's a famous piece of freeway in New Mexico where I live, and they were talking about being able to power a car with ones and zeros. because information is energy, energy is information, the universe is a bunch of ones and zeros. That's the kind of research direction people are going in, and it's not necessarily that. The biggest thing is that as soon as you have a science or an engineering discipline, you are exclusionary. You are locking out huge amounts of the data, huge amounts of reality that you account for with your science, and so you just plain ignore it or say that it doesn't exist. Engineering can't do it. We talk about genetic engineering and biological engineering, and in a real crude way we do. Anytime you use horticulture to breed plants or to breed animals with animal husbandry, you're doing a kind of engineering. But we could not sit down today and write the engineering specs to build a cell. We certainly couldn't do it for an ecology or an ecosystem. It's just beyond the capabilities of engineering. Craft and agility are not enough either. Craft and agility gets us better and better at being this little man balancing up on top of the cliff. We can do cleverer tricks. We can dance closer to the edge. We can do all kinds of interesting things, but it does nothing at all about what might happen when we fall off that cliff. You need to have a different kind of a mindset. Mindset begins with admitting failure. Most of what we do has been driven by this notion from Herb Simon, The Sciences of the Artificial. Instead, we want to change to a different mindset. By analogy, computer science, software engineering is focused on being better capable of building androids like data, building artificial things that become indistinguishable from the real thing. A company like SAP is determined to build a piece of software which is, in a very literal sense, the business, so that all you have to do is tweak the SAP software and you have a new kind of a business. This focus on the science of the artificial. So instead of creating these kinds of mirror worlds, trying to replicate reality inside of a machine or a machine equivalent of it, let's just admit or recognize that our real job is to go out and change the world. Instead of figuring out how to build androids, which is probably a fool's game, let's figure out a way to come in and replace a heart muscle or a neuron in the brain or something small in the natural system so that the natural system is enhanced and continue on the way that it's going. Embrace the alternative. I chose this name, Ars Magna, and that diagram because the founder of computational science, the thing that preceded everything that we know of today as computer science, wrote a book called Ars Magna. And this is a diagram from this book, which was the very first computing device, not calculating device, but the very first computing device. Anybody know who it was? Leibniz is famous for being the inventor of computational science, but he was basing his work on this man's work. His name was Ramon Lull, and he was a Catholic mystic that lived on the island of Majorca off Spain. So we rethink our profession a little bit. We say that we are no longer in the business of building artifacts, big, clever pieces of software, big, clever pieces of computational capability, no longer in the business of building androids. Instead, we are constructing reality. We are literally changing the world around us. Well, let's do it directly. And let's take it seriously. Peter Denning, who has written extensively in software engineering, is a contributing editor to the Association of Computing Machinery, very well known in the profession, said that we should not think of ourselves, or we should not approach this as a profession, but as a calling, with the same deliberate analogy to the calling that a priest has to become a servant in a religion or in a spiritual kind of a tradition. This is a lifelong commitment. Carries with it huge obligations in terms of morality and in terms of responsibility for what it is that you are doing. So we already know that we're changing the world. We already know that most of the people who have to live in that world that we have created for them don't like it very much. People are very unhappy with what it is that we are delivering to them. So instead of doing this the way that we have been, let's do it by design. So let's think about what it is that we are going to design. We're designing the world. Well, the world is a system. Luckily, a system is relatively simple to describe and to define. A system is just a set of components and the relationships among them. An element, of course, may be a system because there is only one system, and that's the universe. Everything else is a subsystem which has been arbitrarily carved out and defined. So any given element inside of a system at this level might be a system at a nested level. But still, this set of components and the relationships among them is consistent across that line. So world design then just becomes nothing more, nothing less than deliberately and from an informed perspective changing an element or changing a relationship in the system. The change might be an addition or a deletion, or it might be a modification. But that's the only thing that we are deliberating about. That's the only thing that we are making decisions about. So then the question becomes, how do we deliberate, and how do we become informed about what that is going on? The other corollary of this, and this could have been one of the major contributions of agility. Agility gave up on supposedly big projects. Our work is supposed to be focused around a story at a time. One thing that is going to make something better. Well, we'll have a story about an element or a component of the system, and one story is going to be our unit of work, not an 18-month project. To be informed, we need to know a lot about systems, which means we need to go back and revisit something that was introduced into computer science in the 60s, at least, by Jerry Weinberg. We need to understand what general systems theorists understand about systems, about how you define a relationship, what kinds of relationship patterns exist inside of a system, the fact that changes in one part of a system percolate throughout the system because everything is connected to everything else, ultimately, directly or indirectly. We need to understand what is the function and the nature of an element that we are changing. So if we're looking at an enterprise, for instance, we really need to understand what an account is in the context of that enterprise. We talk about this with behavior-driven design. The idea is that you go out and you look at the behavior in the real world, and then you try to use that as the metaphor that drives what you do in the software. Just need to elaborate and expand on that kind of notion. As we understand and start to figure out the natural system around us, we can on occasion, or will on occasion, figure out that this particular element or this particular relationship would be enhanced, or the operation of the system would be enhanced if that particular thing was automated. And therefore that requires a computer program to do that. Once you have made that determination, then a lot of what you know about computer science, software engineering, agility, testing, all of these kinds of things come into play, but it's all going to be focused on this very small little component. So we have a new discipline, which is reality construction. We have a new title for all of you. You're now going to be reality architects. You're going to go out and change the world. Deliberately, you're already changing it. You might have some new specializations, like a composite systems analyst. This would be a combination of a cultural anthropologist, a business analyst, a systems analyst in the way that was originally defined, but somebody that actually knows how to go out there and look at this complex reality and say, aha, I know how this works, or at least I know how to start figuring out how it works. The systems designer. These things are going to overlap a lot, obviously, but if you have a really solid understanding of the system, then you're in a position to say, well, gee, if I replace this, it will have these kinds of effects, or probably have these kinds of effects. The system that we're dealing with is not deterministic, so we can't be sure what kinds of effects. We can't determine that the introduction of this software artifact, in fact, is going to change all of the relationships and the culture in which it was introduced and destroy the culture. It's a potential risk. Systems tinkerer. We're no longer going to have maintenance programmers. We're going to have people that are sitting here just tinkering with the system to see what the effects might be, or to be able to fix it. This was a term that came up in a number of earlier conferences, early agile conferences, talking about how the software today is so complex that we can't really play with it or tinker with it or modify it. And they made the analogy to automobiles, that an automobile comes off the assembly line in Detroit, and you used to be able to go in and replace the carburetor with some other kind of thing to enhance performance of the automobile. Or you used to be able to hang fuzzy dice from the windshield to make it look cool. You were able to do all kinds of things to modify them, and you could be a layperson. You did not have to be an automotive engineer to do those kinds of things. Today, even automobiles, you can't do that. You can't go in and update the software that drives your fuel injection system or your automatic braking system. Nobody has the capability in their garage to do those kinds of things. We've never had it very much with software. So this is going to be a person that can do these kinds of things. To support all of this, we need a new way of thinking about what knowledge base we need to have, which means some kind of a new educational system, new discipline. And this is where the bad news, this is where I'm going to make you unhappy, if I haven't already. The only kind of person that's going to be qualified to take any of these kinds of jobs is going to be the equivalent of a modern polymath. We are architects of reality. This is what Vitruvius, who is considered to be the father of architecture, building architecture, said that an architect needed to know before they would be allowed to practice that profession. So before you can go out and mess with everybody else's world, you're going to need an equivalent of this kind of breadth of knowledge. When Vitruvius wrote this, it was a pretty good definition of being a polymath, knowing everything that there is to know. Today, you're not going to be literally a polymath. There's too much to know. But this kind of breadth is going to be a prerequisite. So this morning, Venkat asked you how many of you, well, he didn't ask you. He was going to ask you, or he wanted to ask you, how many of you have read a book this week or recently. I won't be shy. How many of you have read a book this week? One, yeah. Okay. How many of those were nonfiction? How many of you read a really good fiction book this week? And a nonfiction book? The only way you're going to get this kind of breadth, of course, is by expanding the amount of reading that you're doing. And I mentioned fiction books because Alan Kay, as I quoted before, said if you can't read for pleasure, you can't read for purpose. So if you have not had a number of fiction books in your repertoire over the last year, you probably misread that manual, that technical book that you read. How would such a education be delivered, or how would it come into existence? Where would we go to become these kinds of modern polymaths. We would follow the example of one of the later polymaths after Vitruvius, Leonardo da Vinci. Where did he get his education? He got it in a bottega, a studio in Florence, Italy, where he was an apprentice, where he went in knowing nothing, probably swept floors for the first couple of months that he was there. But he was in an environment that was very rich with all kinds of things going on, all kinds of activities. There were multiple disciplines going on in that same room. They were doing things for paying customers. This is a critical part of apprenticeship. If you're not delivering for the real world, if you're not delivering a sustainable product, you're not really learning very much about what it is that you are doing. So it's a storefront. It's a workshop that is engaged in craft, but it's also engaged in reinventing and expanding our understanding of that craft. You can't understand what it is that you're doing. You don't really understand what it is you're doing until you can build a tool to enhance your understanding and to deliver your understanding of what it is that you are doing. A lot of projects, very noisy. Another important thing is that it's filled with exemplars of what you are doing. So Venkat, one of the other things that he said this morning was, how many of you have been reading code lately? Must visit. It is considered to be such a hive of intellectual activity and emergence of new ideas that if you were visiting that area, you could not conceive of not dropping in for a day or two as a way of enhancing your ability to do things. So I just quit after way too long being a professor at a university in the United States. One of the reasons is that although they promise these kinds of intellectual communities and so on, they never deliver on them. The education that you get in a typical university is so sparse, so poor, that it has a tendency to be somewhat ineffective. So the apprenticeship boot camp things that Dave Hoover was talking about earlier today, if you had a chance to visit that, that's much more of an approximation to this kind of an ideal as than any university. Questions, comments, brickbats? No rotten tomatoes, please. Yes. Yes. So Mary Poppendick was talking a little bit about this kind of thing earlier when she said, don't give up on any company that was found before 1990. You are seeing these kinds of trends. People are starting to recognize this fact. They are starting to recognize the need for diversity and diverse ideas coming in, but they are still not where they should be. There are probably a dozen roles that are never represented in any software shop, even at Google. Google does not have, as far as I know, a cultural anthropologist that works with the software development teams. Neither does Apple. They might.
Yeah, I might say that anyone today dreams or whose ambition is to create a startup is lacking something to be a good reality architect. One of the elements, or several of the elements in the system consists of laws and the way you charter a company and what you inherit when you charter a company within the current judicial system and tradition is part of the system that's producing those results, as you said at the beginning, are leading to catastrophe. So, probably there's something beyond startup that needs to be invented.
Oh, yes. So I was in London before I came here, and I was talking with a number of people who have internal apprenticeship programs. There are people here that have apprenticeship programs in the companies that they work for. And we looked at the curricula of those kinds of programs and what they were doing and how they were doing, and it was really cool. But education has two functions. One is to replicate your parents, to create people who are capable of coming out of school and fitting into and working in the society. The other part of education supposed to be is to give you the ability to think and expand human knowledge. The apprenticeship programs, even these in-house ones, they are a step in the right direction, but they're still focused on replication of their existing workforce rather than anything that's disruptive. And the economics are such that you don't really want that kind of a thing, even when you're faced with an example. So one of these companies in London, they were telling me about how they had hired a physicist, knew nothing about writing code, but he was a PhD in physics. And he solved some really difficult problem for them. And they were proud of him because he was one of the graduates of their internal apprenticeship program. So see how much he learned, and then he came in and he did this. So my question to them was, but did he then teach a class in physics to everybody else so that they could have similar kinds of insights or in the future? And the answer, of course, was no. And that's what's missing from our first steps. We're early yet in this process of restructuring and rethinking what we are. So you have to give some latitude and leeway. But yes, other questions? That's difficult to answer without being self-serving. So in the next month or 6 weeks or so, there will be a website out there for Transcendence Corporation. And its mission is to do exactly this, to create the kind of immersive, embedded, expansionist notion, to create people who are these kinds of modern polymaths. The business model is always tricky, of course, in these kinds of things. The people that could most value from this are already working, 40 hours a week. So when you sit down and do something like David Hoover does with his beginners and say, well, come and live with me for 40, 80 hours a week for this short period of time. It is a short period of time. And then you can go out and take your day job. Most people don't have that luxury. So, but you can also do it by just thinking what it is that you might need to know and the sources of inspiration. You can even look within things that the community has already done. So there's a huge amount of work in security, for instance, is based upon biology metaphors. That would be the single biggest thing is, look at all the metaphors that are out there, look at which ones seem to be working and helping us, and then look more into those disciplines because there's probably more there. We'll be talking about patterns at Guru Plop at the end of this conference. That is a metaphor derived from an architect. Patterns are, yes. So the first person to think about and develop patterns was an architect, not a software person. We're talking about software well, not totally about software patterns, but the whole idea, notion of a pattern came from an architect. An architect with a vision of discovering what was the fundamental essence of beauty and liveness in the world. So expand your horizons. Read lots of fiction, and then when you see something cool in the fiction, go and look at the science behind it. And then figure out how it relates to what it is that you're doing in your day job. Is it narrow in the context of the world in which that code is going to be used, or is it narrow in the sense of the machine simulation? So you know, in what sense is it narrow? So, an example of this, in the United States, medical information, everything that is known about you, your health issues, everything else, is stored in a database and belongs to a drug company somewhere. You know, because they're the ones that paid for it and paid for the system and things of this sort. So if you designed, you know, even a very concise, well-defined application that's going to make it easier, in theory, for you to get better medical care, the fact that you're giving it to them makes it not beneficial to everybody. It ends up making it beneficial to the people who have the control, who therefore can derive the money from it. Here in Bangalore, there's a company called Patients Know Best, which is also a medical information system, but the information belongs to you. And you have control over the information, and you decide who you're going to share it with or not share it with. So that would be a solution that is designed that has much more potential to benefit everybody than the former. So you can look at things of that sort, and you can question the ethics of them or the general benefit of them. Yep. Yes.
Instead of simplifying the design, they are unnecessary intentional complexities.
Oh, yeah. So let me generalize that question and put it back on you. You know, that 3 to 5 trillion lines of code out there, how much of it is necessary? How much of it is overhead that was imposed because you were using frameworks and middleware and libraries and whatever? Yes. Yeah, there are some other things. Yeah, so Alan Kay at VPR Research has a project called the Ometa project. Ometa is the language, but Ometa is the language that they are using. Their goal is to reduce by 90% the lines of code in the world. So they are able to take things like the TCP/IP stack, which is several tens of thousands of lines of code, and replicate it in 1,000 lines of Ometa. So they got rid of huge amounts of code. If you go all the way back to the 80s and to the Smalltalk programming language, Smalltalk ran on everybody's computer, which meant it used everybody's operating system, but it didn't need one. You could run Smalltalk directly on bare hardware. And in fact, there was one exemplar. Somebody put Smalltalk on a wristwatch. So you had a full multimedia development and delivery platform on a wristwatch. And it worked. So the idea that we can do these, this kind of simplification is there too. Alan Kay also, the original idea of an object is that every object would have its own IP address. So you'd only create an object once. It could be mobile. Its IP address where it was created would be its object ID, so you have a universal namespace. But then its current location would be tracked by a set of white pages, i.e. the internet, with your web page and a DNS system to help you find the web page. Only now it's down at the level of software. Design is the key. The way that you approach and think about things is the key. If you do not explore laterally into new areas and find new metaphors and new ways of thinking about what it is that you're going to do, you have very little choice but to just continue replicating all these massive amounts of code and complexity. And then reinventing them from time to time. So you need the new, you need different fields of exposure, different kinds of ideas. You need to be that kind of modern polymath. Last question? Given where we are and so on, I would start with Christopher Alexander's, not a pattern language, but the timeless way of building. Nature of order is pretty dense, but if you want to pursue those ideas, Jane Quillian over here has a book called Delight's Muse, which she describes as the Cliff Notes of Nature of Order, which is a 4-volume set. I would go and read John Brunner's Shockwave Writer, published in the 1970s. I would probably read Alfred Korzybski's The Science and Sanity. I'd read the design book that Rebecca and I are writing. I'd read the Ars Magna book that I'm publishing later this year. And I'm sure that many people here have suggestions. I saw 1 or 2 nodding heads at the ones that I suggested, so I suspect all of you collectively have a good idea. Von Bertalanffy's General Systems Theory. Okay, thank you very much.